would you define similar figures as?
Same shape.
What?
Same shape.
Same shape, okay? So what do you mean by the same shape? Okay, we'll write down same shape. Are all rectangles similar? No? Okay. All right, why not?
They don't have the same side.
Okay. Are you thinking congruent or similar? Because you said same sizes. All right, so remember, if we're going to say same shape, you're on the right track, okay? Number one, remember that corresponding angles are congruent, okay? All your corresponding angles are congruent. So if we're talking about, you know, two triangles, then if you have a 30, 60, 90, that's similar to another 30, 60, 90. A 30, 60, 90 triangle is not similar to a 45, 45, 90 because the angles are different, okay? So the corresponding angles have to be congruent, okay? Then there was the second one. Does anybody remember the second one? Corresponding sides have the same ratio. So when I asked about, you know, are all rectangles similar, that's not necessarily true. If the ratio of, say, the heights of the rectangles, okay, are 1 to 2, then the ratio of the bases have to be 1 to 2. If the ratio of the bases are different, then they're not similar. Okay, so the ratio of the sides, all the corresponding sides has to be the same. Okay, so those are our two, you know, stipulations. All right, do you understand ratio? You know what a ratio is? What's an example of a ratio?
2 to 1.
2 to 1. Okay, all right, so one figure is twice as long as the other. Okay, what about scale factor? Do you remember a scale factor?
Oh yeah, for like every inch, but there's going to be like 72 feet or something.
Okay, that could be, that's a good example of a scale factor. All right, and you're talking like in terms of like maybe a blueprint.
Yeah.
An inch on a map or an inch on a blueprint represents 72 feet in terms of real life, okay? So basically remember that your scale factor is your ratio from one figure to the other. So if the ratio of the sides is 2 to 1, then the ratio of the heights is 2 to 1. Okay? So all the pieces of the figures have the same ratio, and that's called your scale factor. Okay? All right, so we're going to add on to this as we go through, okay? And, you know, I always start out with the idea of, you know, the ratio of the sides, okay? So your ratio of sides, which is your scale factor, okay, I always refer to as A to B. A to B being like 3 to 2, 4 to 1, or in Chris's case, 72 to 1, okay? All right, so that's the ratio of the sides is your scale factor. The ratio of the perimeters is exactly the same, A to B. Okay, let's show a quick little example. Okay, if I were to draw a rectangle, and I'll make it like 3 and 4, and then I make another rectangle, and I make it 6 and 8. Okay, so first of all, can someone tell me the ratio of the sides? What would be the ratio of the sides in this case? Or the scale factor? What do you got? Not 3 to 4, because you're going from one side of one figure to 4, the same figure. Scale factor has to go from one figure to the other figure, because we're talking about a ratio between the two. 1 to 2. Why 1 to 2?
First figure is 1, the second one is multiplied by 2.
All right. So 3 to 6, if you simplify 3/6, you get 1/2. If you simplify 4/8, you get 1/2. So like you said 3 to 4 because you stayed on the same shape. But it's 1 to 2 because you're going from shape to shape.
Oh, I didn't even see this on the top.
Does that make sense? Okay. So if our scale factor is 1 to 2, okay, what would the perimeter of the top rectangle be? What would the perimeter of this top rectangle be? 14, okay? And the reason is 3 plus 3 plus 4 plus 4. What's the perimeter of the bottom one? 28. What is the relationship between 14 and 28? 1 to 2, just like the sides are. So notice that the ratio of the perimeters stays the same. Okay? All right, and then the new concept, okay, and we talked about this, both of those already, okay, but the new one is the ratio of areas is going to be different, okay? In this case, it is going to be a squared to b squared. All right, so our a is 1, our b is 2. What's 1 squared to 2 squared become? 1 to 4. Very good. All right, so let's check it. What's the area of this rectangle? 12. So if our ratio is 1 to 4, that means the ratio of this rectangle is going to be 4 times as much. What's the area of this one?
48.
6 times 8, or 48. Is 12 times 4, 48. It worked. Okay? And the reason is because you're multiplying by 2 twice. 3 times 2 and 4 times 2. And that's why you actually end up multiplying by 4. Okay? Does that make sense? Another way to look at it if you're big into pictures is notice that if I were to split this, would you agree that this would be 3 and this would be 3? Would you agree that this is 4 and this is 4? How many rectangles do I have in there that are 3 by 4? 4, because it doubled on both sides. And so 2 times 2 is 4. That's why it's 4 times the size. Okay? This is a very, very common question on the ACT and the SAT. They will simply ask, if you double the side lengths, then you do what to the areas? The areas stay the same, they double, they triple, they quadruple, or they are squared. Okay, and squared is the correct answer. Okay, in terms of if you double, it's actually 4 times, the size. All right, if you triple the side length, it's 9 times the size when you get to the area. All right, questions with that? All right. All right, in example number 1, okay, what is the ratio of the perimeters? And FYI, it's always a good idea to simplify your ratios. And the reason is when you get to ratios of areas, you're squaring with smaller numbers. So, who wants to come up with a ratio of the perimeters based upon the ratio of the side lengths given? Why 2 to 3, Mary? Why 2 to 3 and not 8 to 12?
I simplified.
You simplified 8 twelfths by dividing by 4, and she says the ratio of the perimeters is 2 to 3. Now that you have the ratio of the perimeters, what's the ratio of the areas?
4 to 9.
4 to 9. 2 squared is 4, 3 squared is 9. Questions on that? Okay. Example 2. Two similar triangles with corresponding side lengths of 4 and 7. It's the exact same question as above. Okay, the only difference is they didn't give you a picture. So, find the ratio of the areas. See if you can do that. And then if one of the triangles has an area of 18, what's the area of the larger one? See if you can do that. Talk amongst yourselves at your table. See if you can figure that out. All right, so just to double check so that you have it correct for the second part. What's the ratio of the areas? Okay, I heard 16 to 49. Remember, 4 squared, 7 squared. Okay? So hopefully you're using 16 and 49 in the second part. Figure out the bottom part. So, Chris, what did you do?
I did 18 squared over x, and then I set up like another fraction or whatever. 16,
Ratio.
16 over 49, and then I cross multiplied.
Okay? All right, so remember, we're setting a ratio equal to a ratio. He is absolutely correct. Reminder that when we do this, I always talk about being consistent. So he did the smaller one over the larger triangle. And so over here, the ratio of the smaller to the larger. Okay? All right, so he was very consistent when he set this up, and then he cross-multiplied and solved. Okay? Did you get an x value? Did you get a value for the larger one?
No, I haven't solved yet.
Okay. All right, so here is the big idea, okay? When you want to find an area, okay? Here is what you are going to do. Big idea is you are going to do a squared over b squared, the ratio of the areas. Okay, and that is your 16 and 49, or in this case, 4 squared over 7 squared, because A is 4, B is 7. Okay, equal to the area of A, which is the smaller triangle, which they said was 18, and obviously it's going to relate to the 4, because 4 is smaller than 7, and then over the area of B. And then you cross multiply and solve like Chris said. Okay? So anytime you want to find a missing area, you got to do a squared over b squared equal to the area over the area. Now the number one mistake that people make when they do this is they do the following. They do 18 meters squared over x equal to 4 over 7. What's wrong with that? Right. These numbers don't represent area. They represent perimeter, okay, or side lengths. So this is the number one mistake that they make is they forget to square those numbers because the ratio of the areas is squared, okay? Questions with that? All right, keep that in mind as we go through the rest, all right? All right, second part. Consider the similar quadrilaterals. They have the following area. Can you find the ratio of the sides? Can you find the ratio of the sides? So they're telling you that the area of ABCD is 846 and the area of this one is 376. They want you to find, okay, when they say find the ratio of the sides, they're basically saying find A and B. Any ideas?
So many ideas.
So many ideas? Give me one.
I was kidding.
Oh. You've already done this. Square root. Very good. Because remember that these numbers represent, this is like your a squared and this is like your b squared, right? Okay, so you've got 846 is to 376, and you want to do the square root. Now, simple thing that I would do, just keep in mind, okay? Since there is no square root of 846 and there is no square root of 376, I would type in 846 divided by 376 first. hit enter. And then go math frac and see if it simplifies down to be a smaller fraction. So simplify that fraction. What do you get? What'd you get? All right, so he says this simplifies down to 9 over 4. Okay? So why don't we take the square root of 9 and 4? That would be easier. What's the square root of 9? 3. And then 2. Okay? So the ratio of the sides is now 3 to 2. Okay? Questions there? All right, so now you have to use that ratio for part B. Find the length of AD. Work with the people at your table, see what you come up with. Hint, hint, hint. Think about what Chris did on the last example. All right, so just so you understand, you would have to do 3 is to 2 as x, or AD, is to 24. Cross, multiply, and solve. Okay? You should get x equal to 36. All right?